Yo, so we're back for part 3. In the last video, we stopped with measuring the crankshaft bearings and installing everything. We also did the piston rings. We gapped them and we cleaned them up. So in this video, I'm thinking we'll continue on with that, and we'll start with installing the piston rings, and we can get them installed on the pistons first, and then we'll put them in the engine, and we'll start measuring the connecting rod bearings. We'll measure them with plastic gauge like I did in the last video, and if everything works out, then we can do a final install of them and hopefully be able to get the bottom end all put back together. Yeah, so I'm thinking we'll most likely start off with measuring the end play of the crankshaft. That's the one thing I forgot to do in the last video, so we can get that done real quick and move on to installing the piston rings. So let's do that. Okay, so if we reference our specification sheet, let's see if we can find it here. Crankshaft end play. Looks like it calls for between 3 to 6 thousandths of an inch. So that's what we'll be going for. So normally to measure for end play, you take a breaker bar and you push the crankshaft all the way one way, and you have a dial gauge on this side, and that'll measure the in and out movement of the crankshaft. And depending on the amount of movement is, you check within specifications. If it is, then you're good. But if not, then you have a problem with either the crankshaft or things could be too tight. So in my situation, I don't have a stand for the dial gauge. So what I'm thinking we'll do instead is just push the crankshaft all the way one way and measure with the feeler gauge in between the thrust bearing and the crank. As long as we have a little bit of space, and as long as it's not, as long as there's not too much play, I'll be happy. So let's get that measured out. Move it one way. Trick is just trying to find a good spot. I'm sure there's a designated spot to push it, but I don't know where that is. All right, now we measure the feeler gauge. This right here is 2.5 thousandths. We can get that in pretty smooth, but if I try to get 3 thousandths in, let me grab it. So it looks like 3 thousandths struggles to get in there. It's a bit tight. So it looks like it's between 2.5 thousandths and 3 thousandths, which again, if we check our specifications for end play, looks like it's supposed to be between 3 and 6 thousandths. So we're running a bit small on the end play. At least there's some gap, 2 thousandths or 2.5 thousandths, so it's close to the minimum. I think it's something I'll be okay with running it. I don't think it's going to cause any excessive damage or anything like that. Yeah, if anything, it's just going to wear in a little bit as we start driving it and putting miles on it. So, but if I'm wrong and it blows up, then we know who to blame. So let's just move on to the piston rings. All right. Got the first piston here. This will be piston number 1. I was thinking about measuring them out and measuring them and comparing them to the bores and trying to get them all perfect and exact, but I think we'll be all right. They are just factory pistons, and they were for a different engine, but it'll work. Might not even need the pliers for this one. So these are the oil rings. So drop the first one in. Or maybe I'm doing it wrong. Maybe that goes on first. Okay, yeah. So looks like the part of the oil ring, the middle part, I think that goes on first. Followed by the bottom one. And then the top one. So I got the oil ring on. Let's put the other two on. So it's nice because these are labeled. Lets you know which ones go where. So next is the second ring. You can tell it's the second ring because it has a little step on it. It's hard to tell with the camera. See that? So, sure there's no lint on it. And for this one, I'm definitely going to use the pliers. just so I don't bend it. Don't want to put too much strain on it. And just drop it in. Boom. Alright, cool. And we got the second ring on. Now let's put the top one on. And we'll be done with this process here. The second ring did have a little label, a little indicator that tells you where the top is. This one here, the first ring, I don't think it really matters, the position of it, but I'm just going to have it with the part numbers going up. That seems, I don't know, like a good idea. Alright. Tap with the pliers, open it up, and drop it in. Right now, I'll just go ahead and show you how I'm gonna align the piston rings. So I checked the BMW service manual. It did say to keep them 120 degrees apart. So, for example, you know, where the top ring goes, that's where the gap is right there. It said it didn't want it aligned with the dowel pin, so I'm just gonna put it to the side like that, and then we'll turn the second ring 120 degrees. 120. There's a second ring right there. There's a first right there, and we'll do the same with the bottom two. Yeah, the only thing it said was not to line up the gap of the piston ring to the dowel pin right there. I don't know why. They do spin once you start the car anyway, so it's not like this really matters. But we're going to do it anyways. So the top one is already kind of where it's supposed to be. Spin it a bit more. And the bottom one we'll just move to a different position. Let's move the bottom one over here. Alright, cool. And now we have the piston rings installed and they're aligned. They're good to go. So I think I'll just continue on with doing the rest of them, and when we come back we can move on to doing the bearings. So alright, so finished installing all the piston rings. They're all looking good. So now we can go ahead and move on to the bottom of the pistons, to the connecting rod bearings. We can go ahead and start bolting them, cleaning everything up, and putting the new bearings in. Probably clean these up too with a little bit of acetone. It's going to be the same process that I use for installing the main bearings. Just make sure everything is nice and clean. Use a microfiber rag and some acetone, clean it all off, clean these off, get them all in, and we can start moving on into installing them, and I'll show you guys how I'm thinking of doing that. But for now, this part's pretty monotonous, so I'll just get this done, and when we come back we can go ahead and install everything. So yeah, I'll be back shortly. And we're back. So I finished installing 1 through 5 here. I cleaned the bearings. They're already pretty clean, so I just mainly cleaned the piston itself, the connecting rod, and the caps. But I did find an issue here. If you look closely on the bearings for number 6, these are brand new. This one's okay. This is in really good shape. This one looks like it was, I don't know, looks like there's a chip. And these are brand new. This wasn't something I caused when I opened it. I didn't notice it until I was on the last one. That's when I noticed it. I was like, oh man. It's just a bummer because now I gotta wait. I gotta order a new set and I gotta wait for them to show up. It is a bummer. Honestly, I was considering whether or not I should just run it. I still, like, I could possibly. I don't know if it would work or not. But I'm just paranoid about it, so I'm gonna go ahead and replace it and gonna have to wait like 3 or 4 days for it to show up. So I guess in some sense it's worth just getting a new set, because we're already doing all the work. Everything's torn apart, so it's best just to do it right now, replace it, peace of mind, rather than throw it in and risk it going bad and being screwed. So yeah, it's a bummer for me, just because I want to get everything buttoned up already. I guess I have to work on my patience a bit, but yeah, just an update. Stuff that happens with engine builds. No bueno. And I have returned with new bearings. They showed up. It only took about 2 days for them to show up, so that was good. So now we have all the bearings installed, all the piston rings installed, and they're cleaned. So everything is good to go on this part, on this end. So let's switch the camera over to the blocks perspective, and let's start prepping it for the pistons. So there's many different ways to check the connecting rod bearing clearances. You can do it with the crankshaft out of the engine. You can do it with the connecting rods by themselves on a vise. The way I'm thinking of doing it is installing it in the engine and just using plastic gauge to double check the measurements. It seems like the simplest way for me, honestly. And what I'm thinking of doing, my plan is to do 2 pistons at a time. Whichever pistons are connected, essentially, since this is an inline 6, there's always 2 pistons that are moving on the same plane. I think for this one, yeah, right now it'd be 1 and 6. They're connected, so I'm going to start with 1 and 6. The way I'll do it is first I'll clean the cylinder walls with some ATF. ATF does a better job than brake clean of just getting all the extra gunk from honing. So first I'll wash it all down with just some ATF, just clean it all off real quick, and then I'll oil it. I'll just give it a little bit of oil just to lubricate everything. I'll also oil the pistons, the piston rings. Just make sure everything's lubricated. Slide them in, and then we can start measuring the bearing clearances. I'll flip it around. We can measure 1 and 6. Once they're measured up and we know they're good, I can do a final install of those 2 only, and then we can move on to the next 2. Let's go ahead and start cleaning the cylinder walls. For ATF, I just bought some standard stuff from Amazon. I doubt it matters. They all have similar properties. I think what's so special about ATF is just all the detergents that it has. So it's not only a lubricant, it also cleans. And I did do this previously. I'm just kind of double checking everything. So I think for the most part we'll be okay here. I'm not seeing much material on the rag. It's looking pretty clean. If it is super dirty, I'd recommend just doing this over and over until you don't see any debris left on the towel. Hopefully my honing job is adequate. Many worries here. And if you last remembered, the crankshaft is already clean for the most part, so I don't really have to worry too much about that. When I drop it in, I'm just going to try not to move the crankshaft at all, since everything, there's going to be no lube on anything pretty much. Alright, now I just have some regular oil. Yeah, I'm just going to wipe down the cylinder walls with it. Alright, now it's time for piston installation. For that, we're going to need a special tool. These are piston installation tools. There's many different kinds to choose from. There's the cheaper Harbor Freight kinds. They're really cheap. I think they're like $10 or something. I have one. I just didn't want to use it because they are like a universal type. They're a pain to work with. I didn't want to work with it, so I just went ahead and spent a little bit of extra money to pick up the proper sized piston ring compression tool. This one here is as you can see here. That is the size and the part number. I believe this is Wiseco, and it's the exact size that we'll need anytime. If in the future we'll be doing more work with M50s, we can just reuse this. So to do this, I'm just going to go ahead and lubricate the inside of it, and just make sure it's well oiled. I'll do the same to the piston, and the magic of this tool is it's concave, so it's like a funnel. It'll compress the springs down. So now we have to orientate the piston the proper way. So it does have an arrow at the top. Let's see if you can see it. It's kind of hard to spot. Oh, there it is. See that arrow? That arrow just points to the front of the engine. So we'll take it. Let's try to be gentle about it. Or actually, let's try compressing it first. Okay. Just push it in. And now, voila, it's in. All right, I got the cap just loosely screwed on the underside. This is kind of, when I go to flip everything, it'll just kind of be insurance that the piston doesn't come flying out. So, all right, number 6 is next. And down it goes. There you go. All right, we're looking ready to go here. Before I get started, just want to consult the specifications real quick, just to show you guys. So for connecting rod bearings, we are looking for an oil clearance of between 0.8 thousandths, so 0.0008. That's what is it? 8 tenths. So 0.8 of a thousandth to 2.2 thousandths. So these are our measurements down here. That's the millimeters, 0.02 to 0.055. So that's what we're shooting for. And the measurements are the exact same as the main bearing, surprisingly. I already have the plastic gauge ready to go, and I'm just going to be holding, I'm just going to be hovering my hand over the bottom of the bore here in case the piston decides to go flying out. This is one of those times where having a second person would be really nice. There you go. Let's see if I can do this with gloves on. Alright, that ought to be good enough. Alright, cool. We passed the dangerous part here. So now you just got to be careful about twisting the crankshaft. I am using the old bolts here just for tightening everything and for checking the clearance. I will be switching over to the new bolts. I did get new bolts as well for the rods. So the torque specs for the connecting rod bolts are 17 foot-pounds initially, followed up by 70 degrees. So if you remember, the main bearings were 17 foot-pounds with an additional 50-degree turn. This one, for the rods, it's calling for 17 degrees followed by 70-degree turn. So double check everything. Alright, so there's our plastic gauge mark right there. That line, we measure that up. Let's see what we get. It's hard to tell because you guys are in the way. That's looking like 1.5 thousandths to me. Yeah, it's definitely too small to be 1,000th. That's dead on. Wow. Just like the main bearings, They're exactly at 15 thousandths, or not 15 thousandths, 1.5 thousandths clearance. That's crazy. It's pretty accurate. Alright, so clean the plastic gauge off using a bit of oil on a rag here. And as you can see, it's coming off. So plastic gauge is definitely oil soluble. So I'm going to push the piston down a bit, double check that the journal is clean, and let's just start looping everything up here. There's the cap, make sure it's on the right side. Yeah, notches line up on just right next to each other. Alright, gonna put a little bit of oil on the bolt here, on the threads. And these are the new bolts, so this will be the final torque down of piston number 1. Alright, so piston number 1 is now assembled. So we're good on piston number 1, and we're going to repeat the same procedure for number 6, and then from number 6 we'll rotate the crankshaft, and we'll do 2 and 5, and then we'll do 3 and 4. Double check that they're good. Alright, here's the oil pump and pickup tube. First we'll start by just cleaning out all the silicone that's trapped in the pickup. Somebody went ham at one point. Quite a decent amount, honestly. So let's take off the pickup tube here. We'll be replacing the gasket for the oil pickup tube. Here's a new one. Just to avoid any future problems with loss of oil pressure. New gasket is in. Let's install this in the car, and we can install the gear as well as what we'll be replacing the regular nut with this drilled oil pump nut. So let's get this on. I just did a quick Google search, found somebody said 16 foot-pounds, so that's what I'll be setting it to. Honestly, I'm not really too worried about the bolt torque spec for any of these, or the baffle plate, any of this stuff. As long as you make sure it's snug, it'll be good for the most part. So we got these tightened down. Let's go ahead and install the oil pump sprocket. Put it on either way, and This might be a bit trickier than I thought, actually. So that goes on. And this goes on. That goes on like that. And this goes on like that. Something that I noticed, this non-Vanos engine did come with a tensioner for the oil pump, sprocket. The other two engines that I had that were Vanos did not come with that. So let me show you the tensioner. Check it. So this is what the tensioner looks like. I think it goes right here. Yeah, and it just kind of pushes up against it. I don't know what's better. If anybody knows what's better, let me know down in the comments. Tensioner or no tensioner? Let's try the other chain. Yeah, this one's much tighter. So this chain is off the Vanos engines, and it's way tighter. Way more of a snug fit. I guess you could always leave the tensioner on too. But yeah, this is pretty snug. A little bit of play. Okay, so let's install the special nut. So this is a drilled oil pump nut. It's different from the stock, as you can see, it has those holes right there. This is reverse thread, by the way, as well, so it's left-handed threads. So you got to screw it on the opposite side, like if you're loosening it, and that tightens it. Like so. So this is a special nut. The reason why we'll be using this is because these standard nuts, once you turbo the engine, it puts a lot of force on this nut, and they like to come loose. And if they come loose, the oil pump spline comes off, and you lose oil pressure. So a lot of people will either tack weld this on, or they'll buy a kit like this that comes with a piece of wire here that runs through the oil pump nut, and you just tie it off to the sprocket itself. Before I put the nut on, I'm going to go ahead and I already cleaned the threads here. I'm just going to hit them with some red thread locker. This is just some time served stuff that I have lying around. See, I'll probably hit the nut here, and I'm using the red kind just to make it extra difficult for it to come off. We're going to torque it to 24 newton meters, which I think it's 18 foot-pounds. Okay, I don't think this is working. That feels way too tight. Alright, I'm back and I got this torqued down. So one thing, be careful with the torque wrenches. Yeah, so it turned out as I was tightening it, I was getting pretty sketched out because I felt like I was putting a lot of pressure on it. So I let go and I just flipped it to the proper direction, clockwise. Went to check it, and I mean it was past what it was supposed to be at for the tightness. Even though I had the torque wrench set to 18, it was well beyond that. So I guess reverse counterclockwise doesn't work on this torque wrench, which is pretty sketch. So now we'll do the safety wire. So for the safety wire, since the nut is spinning to tighten it, it's counterclockwise, so it's going to loosen clockwise. So we want to prevent it from loosening. So we're going to want it going this way here, this way, just to kind of keep it from wanting to undo itself. So first, just run the safety wire through the nut. And you can use safety wire pliers. That's kind of what you're supposed to use. I forgot to pick some up, so we'll just be using standard pliers, and hopefully that'll be adequate enough. Alright, got the wire tightened up here. So what I'm planning on doing is wrapping it around, maybe multiple times, maybe one time, and just kind of bend that toward itself. So now we got that on the oil pump, and hopefully if the safety wire's done properly, which it's not, but hopefully it should be enough to keep from spinning. Alright, let's move on. Alright, so now that we have the oil pump the oil pump sprocket, the nut is safety wired, all that fun stuff. We can move on to doing the front timing cover. I already installed the chain, the sprocket, the guides here. I also put in the guide for the oil pump. I just thought, why not? You know, we already have the pin that comes out for it, so might as well just install it. That way we'll have some tension on it so it doesn't come loose. But now we can go ahead and put on the front timing cover. Here's the front timing cover that we'll use. Here's the rear main. I already went ahead and cleaned off the block here. I just used a scraper and some acetone to wipe off the oil and grease. This scraper works really well too, by the way. It's a Goodson. It's a carbide. I think it's tungsten carbide or some kind of carbide end bit here. But now we can go ahead and replace the front main seal and the rear main seal. I just figured might as well, since we're doing all this work. This is for the rear main, and I got the seals right here. So right now I'll just go ahead and start installing them, and then after that we can start drilling out the bung that we're going to need for the oil return for the pan. Here's the bung. It's going to be an AN. It's going to be a -10 line, pt.3. So let's do the front seal, the rear seal. We'll finish installing the timing cover as well as the rear main, and then we'll end it off by welding up the bung there, and we'll put the oil pan on, and we'll call it a day. So let's get to work on the gaskets here. All right, so now let's talk about the -10 bung, welding it onto the oil pan. So this is the old oil pan that I was using. It's got some cracks on it. It's got a bunch of debris in it, so I'm not going to be reusing it. But as you can see, there's the bung I'm talking about. So something I'm going to do different, I'm going to go ahead and try to make it more of an incline, because when this is sitting flat on the engine and it's inside the car, it's actually pointed downwards like that. So I'm going to try to change it to where it's actually on an incline. That way the oil will just flow in a lot easier. To do that, I'm going to have to add on to the bung. So this is the bung itself. What I'm thinking of doing is I bought this tubing off Amazon. I forgot the exact sizing for it. So this is the bung, this is the pipe. It fits perfectly onto here. As you can see, it fits onto that lip. It just pops right in. I'm going to tack it up, weld this all the way around, and just figure out kind of a good size, where to cut it, and leave it at an incline like this, weld it out, and we'll call it good. I have another oil pan too, by the way, but first let's tack this up and weld it out. It's a bit cold, but I think it'll work. I'm just gonna aim for right here, right below this fin here. This will be a good spot. This is where I welded the other one. It sucks because it's kind of hidden behind this baffling. So I'm just gonna have to be careful about debris and aluminum shavings getting in the oil pan. I was thinking of aiming over here, but since everything's out, it's hard to tell if this would be a good spot. So I'm just gonna aim for the same spot where I welded the other one out. And yeah, I'm just gonna try to hopefully prevent any flakes from getting inside the pan. I'll probably stuff some napkins or some shop rags in the backside, and I'll try to keep it at an incline. And I'll just try to clean everything up. All right. So there are still some shavings in here. I'm just gonna try to get them out. At least I can see most of them, and the rags definitely help to keep a lot of the shavings out. Just gotta be careful. I'm gonna try to clean this out as best as I can. Alright, now I'm just gonna heat it up on the outside just to kind of evaporate some of that oil that's been caked into the pan. I tried cleaning it off as best as I could, but I'm still gonna guarantee a dirty weld, so hopefully I don't get one, but we'll see. Alright, let's cut this. Alright, so I left about 1.5 inches, maybe. I just kind of eyeballed it. I have a pipe left. Deburred it. See how it fits. There's a hole. So if anything, I might have made the hole a little too big. I don't know if you can see that. There's some play in there. So I'm definitely not going to make it easy on myself with welding, that's for sure. But I'm thinking I'm going to angle it up like, I don't know if you can see it like this. I'm going to leave it angled up. Just give it a couple tacks. And then weld it out. Woo! Oh boy, is this ugly. Yeah, I'm not too great at welding onto oil pans here, as you can see. It's hard for me to set it up to where it welds clean. I know there's also a lot of oil trapped in the metal. It doesn't help. Yeah, not the best welds, but I got it on there. Took a look around. Doesn't seem like there's anywhere where a leak could form, so I'm pretty positive that this will hold. So now that we have that installed, what I'm thinking of doing is, before we install it on the engine, I'll probably just run a little bit of oil through it just to kind of wash out any of the flakes that are in there. I did the best I could to clean everything out. Let me flip it around. It's still pretty warm, but as you can see, there's not much. It looks pretty clean in there. I'll probably still run a little bit of oil just through here, just to kind of help collect all the remaining flakes, and then just drain it all out. But yeah, so now when this is going to be sitting like this, the bung will be sticking at a slight incline, which is better than how I used to have it, where it was at a decline. So this will help just kind of put all the oil back into the engine. Just wish it looked a little nicer, but it is what it is. I'm still learning as a welder, so yeah, so I'll just do that off camera, and yeah, when we come back, we'll go ahead and install this on the engine. All right, so first thing, I put a little bit of RTV. Well, I put a lot of it on the rear main here. I was mainly trying to get the space in between the rear main like housing and the block itself. I ended up putting it on top of the entire top lip of the rear main here, just for, I guess, preventative maintenance. I don't know. And I also put some here in between the cracks for the timing cover, the gap there. Kind of keep that from leaking in the rear main, just to really try to prevent any leakage from the back. So let's go ahead and install the oil pan. Alright guys, it's about 8 in the morning. I've been working all night to try to get this done, and oil pan's on, it's done, it's installed. The bottom end is now complete for the most part. We still have to do a bunch of small stuff, but I think I'll save that for the next video. So that'll do it for part 3. If you guys liked it and enjoyed it, I'd appreciate it if you hit the like button, subscribe. Really appreciate it. Hopefully we'll be making more videos like this in the future, and we'll be doing crazier stuff. So yeah, without further ado, I'm gonna head out. I'm gonna go to sleep. But yeah, hopefully I'll see you guys in part 4. So take care.